Look around you right now. The screen you're watching, the chair you're sitting in, the literal air you are breathing. Today, we are taking on a massive, almost universe-sized challenge. We're going to learn how to classify all of this chaotic physical stuff into neat, understandable categories. Whether you're looking at a smartphone or a star, by the end of this explainer, you'll have a mental map to figure out exactly where it fits. But before we can start organizing the universe, we kind of have to define what it's actually made of, right? You've probably heard the word matter a million times. But if a friend put you on the spot and asked, hey, what exactly makes up everything around us? What would you say? Well, here is the official scientific breakdown. Matter is anything that has mass and occupies space. That's literally it. It's super simple but absolutely profound because it applies to the entire physical cosmos. If it has some weight to it and it takes up physical room, boom, it's matter. Now, matter doesn't just exist in one single flavor. It exists in various states, and each one has its own unique physical characteristics. You're definitely familiar with the big three: solid, liquid, and gas. But there's also a fourth state, plasma. Yet, regardless of whether a sample is a solid rock or glowing neon plasma, we classify it all based on its underlying composition. To tackle this, we use a master flowchart. Think of this decision tree as your primary cheat sheet for the day. Every single time you look at a sample of matter, you can use this map to figure out its identity. And the very first big question we ask is right there at the top. Does this stuff have constant properties and a defined composition? That single question creates the very first top-down split in our map. We are essentially asking, is this material always exactly the same at a chemical level, no matter where we find it? Or can it vary? If its properties can change, we head down the mixture route on the left. But if it has constant properties and a set composition, we follow the yes path to pure substance. Let's actually explore that yes branch first. A pure substance is a material with a uniform and defined chemical composition. The absolutely crucial point here is that you cannot break these down into simpler components just by using physical methods. You can't run a pure substance through a coffee filter and expect to separate it out into different things, because it is fundamentally composed of a single, uniform type of stuff. Continuing down that yes branch, we ask our next key question. Can this pure substance be simplified chemically? This gives us two subcategories, elements and compounds. Elements are made of just a single type of atom. Compounds, on the other hand, are chemical combinations of two or more different elements that are locked together in a defined ratio. Zooming right down to the microscopic particle level makes us so much easier to see. For elements like oxygen or hydrogen, every single tiny sphere in a cluster is exactly the same, representing just a single type of atom. But with compounds, like water, which is H2O, you have different atoms actually bonded together to make a new molecule. It's a very specific chemical recipe. Let's take a quick beat here and make sure we really have these building blocks straight. Atoms are the essential puzzle pieces, made of protons, neutrons, and electrons. An element's actual identity, what makes carbon act like carbon, is defined entirely by the number of protons in its nucleus. Then we have molecules, the smallest units of a compound, and compounds are those specific combinations of elements. I mean, water wouldn't put out a fire without that exact H2O structure. Okay, let's jump all the way back up to our master map. Remember that very first question at the top? What if the answer was no? What if the matter does not have constant properties? Well, then we cross over to the left side of the chart and we are looking at mixtures. A mixture contains two or more pure substances, but crucially, it has a variable composition. They are just physically mixed together. And just like with pure substances, we have a follow-up question for mixtures to further classify them. Is it uniform throughout? Basically, does this mixture look exactly the same from top to bottom, or can your eyes pick out the different individual components? This splits mixtures into our two final categories: homogeneous and heterogeneous. You can easily see the difference when looking at everyday things. A homogeneous mixture, also known as a solution, is completely uniform. Think about salt water. The salt dissolves completely and you just can't see the individual salt particles at all. But a heterogeneous mixture has a non-uniform composition. You can literally distinguish the distinct parts. Think of oil and water separating into distinct layers, or even simpler, a salad. You can easily see and pick apart the tomatoes from the lettuce. Which brings up a really fascinating practical question. If mixtures are just physically combined and their parts keep their individual properties, like those tomatoes and lettuce leaves, how do we actually separate them in chemistry or out in the real world? Well, the great thing is, since they are physically combined, we can separate them using physical methods. We just exploit the differences in their physical properties. We can use filtration, which relies on differences in particle size. We can use decantation, which is simply pouring off a liquid to leave a heavier solid behind. Or evaporation, which takes advantage of different boiling points to turn a liquid into a gas, leaving any dissolved solids behind. So let's look at our complete classification tree one last time. I want you to firmly cement this flowchart in your mind because you now have the tools to classify any matter you find. You see a physical sample. Ask yourself, does it have constant properties? If yes, it's a pure substance. Is it one type of atom? Element. Multiple elements bonded? Compound. If it doesn't have constant properties, it's a mixture. Does it look totally uniform? Homogeneous. Can you see the different parts? Heterogeneous. I'm going to leave you with this final challenge for your day. The next time you grab a simple glass of tap water, really look at it. Based on everything we've just covered, is that tap water truly a pure substance, or is it actually a mixture? And more importantly, using the physical separation methods we discussed, how could you prove it? Take a look around you today. The whole physical universe is just waiting to be classified. Thanks for joining me on this explainer, and keep exploring.